In this college algebra lesson, we are going to be talking about modeling using variation. And the main idea here is that we are going to apply power functions or the reciprocal of power functions to a real-world situation. So there are two types of variation. The first is direct variation. For direct variation, we say that y equals k times x to the n power. Y varies directly with a power of x. K is some non-zero constant. And usually we find k by looking at given information. Find with given info. And we'll look at two examples coming up. But for x positive, a power function is going to be increasing from 0, 0 up to the right. And so that's what the graph for direct variation looks like. Inverse variation is y equals k divided by x to the n. So here we have the reciprocal of the power function. So we say y varies inversely with the power of x. And again, k is a non-zero constant. And if we wanted to draw the graph, reciprocal power functions when x is positive look like this. So now let's look at an example. The distance s that an object falls varies directly with the square of the time t that the object is falling. If an object falls 16 feet in 1 second, how long would it take for the object to fall 144 feet? So the distance s that an object falls varies directly with the square of the time t. If an object falls 16 feet in 1 second, how long does it take for it to fall 144 feet? So s varies directly with the square of time. So we write the equation s equals k times t squared. S varies directly with the square of time. Okay, we are given that the object falls 16 feet when time is 1 second. So now we can set up an equation and solve for k. We get 16 equals k times 1 squared. 1 squared equals 1, and k times 1 just equals k. So we find out that 16 is the value of k. And now the last question is, for how long does it take for the object to fall 144 feet? We need to find the time when s, the distance, is 144. So we set up an equation, 144 equals 16 times t squared, because distance varies directly with the square of time. Dividing both sides by 16, we get 9 equals t squared. Taking the square root of both sides, the absolute value of t equals 3, but time is positive in this situation, so time equals 3 seconds. So for this problem, we see that we had to use the definition for something that varies directly. And we'll do one more example. The volume V of a gas held at constant temperature varies inversely or indirectly. We could say either way, inversely or indirectly, as the pressure, P. If the volume of the gas is 1,200 cubic centimeters, when the pressure is 200 millimeters of mercury, what is the volume when the pressure is 300 millimeters of mercury? So, first piece of information is that volume V varies indirectly as pressure P. So, inverse relationship. So we get V equals K over P, where K is a non-zero constant. We are given the information that the volume is 1,200 cubic centimeters when the pressure is 200 millimeters of mercury. So we set up an equation, 1,200 equals K divided by 200. Solving for K, we multiply both sides by 200, and we get K equals 240,000. And finally, we're asked, what is the volume when pressure is 300 millimeters of mercury? So volume equals K divided by P, the pressure. We found K to be 240,000. Pressure is 300. Doing the division, we get volume equals 800 centimeters cubed, or cubic centimeters. So these two examples that we just did is showing us a relationship for variation. There is direct variation, where y equals k times x to the n, and inverse variation, or indirect variation, is where y equals k divided by x to the n power. We use any given information to solve for k.